Now we look at data selection in series. I'm going to clear this to make room for space. Okay, now let's create our series data equals pd delta series, and then we can create this from a Python list. We can do 0 0.30, 0 0.45, 0.26, what about 0.75, 1 2 3 4, one more, 1.2, and then we can set our index. Remember we said series, they have explicit index that allows us to retrieve and modify values. Okay, so we can modify the value of our series, but then the index object by itself we cannot modify any of the item there, which is a good thing. That's the immutability. All right, so then we can do index equals this is on the array. Let's call this A, and then let's call this B. Then we can call this C. Then we have 5 items there. Okay, and then let's call this D, and then let's call this E, like so. Okay, so when we do data, so we have this. We have our index which carries this label A, B, C, D. Now we label our index. If we do data, we can also use the index directly. 1, this is going to give us, say, 0.45. So this is still index 1, although it has label B. So which means we can do data, and then we can do label B. So we still get the same thing, 0.45. So our index carries these labels A, B, C, D, E, which is interesting when you think about it. Now, we can retrieve values like this, and then we can also perform dictionary-like Python expressions to examine our keys and values. For instance, if we can do A in data. This is going to return a boolean. So this is true. We have an index label A in our data. Then we can get our keys, data.keys, like this. And then this gets us our keys, which is our index array, and this index objects. Okay, now we can also do something like, if we do list, and then inside here we can do data.items. Okay, so if we do this, we're gonna get a tuple. We're gonna get a list. Inside our list, we're gonna get a tuple, and each of the tuple is gonna comprise the index and the value in our data series. So when we do this, let's see what we get. Okay, so now we get this list, and then we get this tuple in our list, and each of the tuple comprise of the index or the label and then the value in our series. Okay, now we can also modify. Remember, this is series. We can modify, even in data frame, we can modify our values. So we can do data, for instance, and then we can do say we do D, and then we can set this to 2.25. Then when we do data, so that's 2.25. Okay, so that works. And then the type is float 64. So that is mutability. Now, we've not done for slicing. Let's try to see how slicing operation works. So for instance, if we do data, and then we slice, let's say A, and then C. Let's see what we get. Okay, so we get from A to C. A 0.30, B, C, like so. Okay, now we can do, we've done for slicing. What if we try to use pay attention to this, what if we try to use the integer index, not the label itself? Okay, so this is going to give us something of an implicit integer slicing. What I mean is, if we do data, and then in here we do 0, 2. All right, 0, 2. Now let's see what we get. Now you realize that this is not as explicit as this, although it starts from 0, but then it stops at, what is it? This is our data, right? So this starts as 0, and then the 2, 0, 1, 2, but then start one step before 2. So that's for implicit integer slicing. We're going to see how to resolve this apparent confusion when we get to lock and high lock. Okay, we're about to get there anyway. Now we can also perform masking. For instance, we can do data, and then in here we can do, well, is data greater than 0.3, for instance, and data is less than 0.8. So this is going to, let's see what we get anyway. Let me let cat out of the bag. So for here, our data greater than 0.3 and data less than 0.8. So this is and operator, so both has to be true anyway. So let's see. Okay, so now we get an error. The series object is not callable. I think I've blundered in that regard. Okay, sorry, I'm sorry. This is what I was supposed to do. Sorry, it's masking. So I'm gonna go back to data greater than 0.3, and then data is less than 0.8. So let's see what we get. Oh, it's still blowing up. What did I do wrong? Again, so here we have data greater than 0.3, and then data less than 0.8. Okay, so now we get 0.45 because we're in our data, the value greater than 0.3 and less than 0.8 is 0.45, right? Okay, so that works good. What else can we do? We can also do some kind of fancy indexing. We can do data, and then in here we can do, okay, let's have a list as well, and then let's have A and then E. Let's see what we get here. Okay, so we get 0.3, 1.2, like that. Okay, now let's look at indexers such as lock and iLock. So the way we're going to do that is, let's do data equals pd.series, and then in here let's have a, b, then let's have a c, and then for our index we're going to set that to 1, 3, 5. Guys, please pay attention here. Alright, now let's see what we get. We'll do data. Okay, so now we get our values a, b, c, and then we have this index 1, 3, 5. Good. Now let's do explicit index. We can do data explicit index now 1. Okay, let's see. Now we get a, right? Good. Now let's do implicit index slicing. When we do data and then we do 1, 3, 1, 3. This implicit, right? Good. Now let's see. So what do we get? We get BC, right? BC, as we should anyway. Okay. Now you realize that these may cause some kind of confusion, because 1, 3, where it stops, is 0, 1, 2. 1, 3 is supposed to stop a step before the last index. So if this is 0, 1, 2, you expect it to stop at 2. Okay, but then we have 1, 3, so it start here and then it stop here anyway, which is implicit. Now you realize that in the case of our integer indices, this thing that we're doing can cause some kind of confusion, this implicit explicit indexing. So what Pandas does is Pandas provides us a special indexer attributes that explicitly expose certain indexing schemes. So for instance, we can do for instance, let's do data.lock. So this lock attribute, I'm not going to let the cat out of the bag. I'm just going to do pass 1 here. Let's see what it does. Now we get a. See, it's using the index value that we assign here. So if I do data and then I do dot lock and then I pass 3a, fingers crossed, let's see what we get. See, we get b. It's using this explicitly such that if I do data dot lock and then I pass 2, let's see, this blows up because we don't have 2 in our index. So the confusion we're experiencing prior to this data flow, it's been resolved with this special lock attributes. So we can do explicitly, we can do data dot lock. So when we're retrieving value, we can only use these index values that we have here in our series. So if I do 5, for instance, we're going to get C, like so. Good. Now we can also do for iLock attributes. Okay, let's not forget we can slice. So if I do 1, 1, 3, so we get 1A, 3, B, like so. Good. Now for we also have iLock attributes. The iLock attribute allows indexing and slicing that always reference the implicit Python style index. So for instance, if we do data.ilock and here we pass 1. This is going to get us B. Check this out. So we get B. So this one is not explicit, this one is implicit. Alright, so if we do data.ilog and then we pass 0 here, this gets us the first item A. And then if we do data.ilog, then we pass 2 in here, that gets us C, the last item. Okay, so guys, that's for data selection in series. Next up, we look at data selection in data frame.